Solid is a set of 5 principles that help you write software that's modular, scalable, and maintainable. The approach was created by Robert Martin, or if you've been in the PHP world for any length of time, Uncle Bob. He's also the guy that originally created the Agile approach to project management, but that's for another video. Let's quickly cover a practical example for each one of the principles that we create in Solid, starting with the easiest, the single responsibility principle, or SRP for short. Essentially, this principle is the thought that any entity, whether that's a class or a method in your project, should only do or be responsible for or concerned for one thing, one area, one layer of your project. Two common areas in Laravel where this principle is usually violated is your controllers and your models. In these areas, the canonical requirement for SRP is that your controller method should only ever be interacting with the HTTP lifecycle, or the request essentially. And depending on your level of abstraction, your model should only ever be concerned with transforming or modifying data for your current instance of the model. And as a quick example, let's say that we're given a naive product controller like this one, with a few common tasks related to creating a product. Let's make this adhere to SRP really quick. So since we're in the controller, obviously we're going to want to limit our responsibility or our concern or our layer, whatever you want to call that, to a single portion. And that's the HTTP lifecycle, or essentially the request. So we're extracting data from the request, interacting with headers if needed, creating responses, things like that. Now, obviously here in this controller, we're doing more than that. And you'll find that as you look at your controllers, just like this one, in many cases, the logic that's unrelated to the current responsibility you're looking at can be moved into event listeners or observers. That's a really common refactoring that can happen when you start doing SRP in your project. So instead of modifying the inventory count directly in the controller here, we can abstract that to a model event instead, which is a much more sensible location for it. Whenever a product is saved, in this case, we can decrement the inventory available for that product. That makes sense, right? The same is true for this search index update. This project is using Elasticsearch as the search solution here, but regardless of what it is, it would probably be better served in a model event as well. And behind the scenes, this is pretty much exactly what Laravel Scout does, is using model events on the search index stuff. Notifications down here, that's what this block is. Those can also likely be placed in a model event as well. Whenever the product is saved, in this case, we just notify whoever in the team needs to be notified. So of course, quickly, here's what that controller would look like after we did that abstraction for adhering to SRP. Now, it's definitely easier to read and understand, especially if you're coming back to this 6 months later for maintenance or something like that. And it's certainly doing fewer things. That's absolutely true. Just to really quickly show you what this service would look like that we abstracted to, that's what it looks like. Essentially, we've just moved that code from the controller that we can see here originally into a service that we can call from the controller method. Now, of course, if your project is just starting to think about solid principles, things are probably now in a slightly better state than they were before. That's absolutely true. But what I want to emphasize in this video, more so than the typical adherence to each principle, is that you should always be reasonable with the application of these principles. Really take a moment to consider, when I make this change to adhere to this principle, are we reducing the bloated nature of our controller in this case? Or are we simply moving that bloat to another file and calling it better just because we adhere more closely to a principle? Are we taking advantage of the features that our framework offers? Is there an unexpressed concept in the domain of our project here? For example, looking at this for each block in the service here, this is actually sending notifications and things like that to users as a part of the team that it's related to the project. But really, we're using a term over and over again that's not present here officially, notification. If this project were using those heavily, which it is, that logic would probably be better expressed as a first-class model. We should make a notification model and use that model in the event to interact and send emails instead of trying to explicitly define it here in a service or in the controller or somewhere else. So, summarizing single responsibility, your classes and methods should only be concerned with one layer or one responsibility. Definitely pay special attention to your controllers and your model. That's where things typically start bloating, and SRP or single responsibility could definitely be applied to a Laravel project. And finally, just be judicious with your application of SRP. Make sure you're actually solving the problem and not just adhering to a principle just because you were told you should. And next is the open-closed principle. And this one states that entities should be open for extension, but closed for modification. And really, in everyday terms, that just means that you write your classes in a way that lets you add new logic without altering anything you've already written. I tend to call this writing in an extensible fashion or writing extensively. And this one really, it makes more sense with an example. So let's just say we've written an order controller and this controller needs to charge for the order the moment it's being created. Now the user of this app should be able to select their default payment method, but the client originally asked us to use only Stripe. So we wrote something like this. Now this is intentionally naive logic. This is of course a theoretical example, just to make it easier for us to focus on the principle itself. In real life, you should do much more, especially when you're charging for an actual product. You're hitting someone's payment source, their payment method, a card, ACH, whatever it may be. You should definitely do more verification and validation here. Anyway, you can see that it's pretty simple right now. We're creating the Stripe client, doing the charge, and returning a response. And really, that works fine, right? But you can probably already predict the issue with this code. Let's say a month later, the client asks that we also support Amazon payments, right? So we go back into our code. It's a month later. We're in maintenance mode probably. We just want to add some sort of gateway or some sort of logic to let us add this Amazon payments logic as well. So we decide to just use a switch statement. And so if we come here, this is what it looks like now. In this new version of the controller, we are getting the selected gateway from the user. If they selected Amazon, we output that logic specific to Amazon. Otherwise, we fall back to our default Stripe client. And again, in real life, you would do something a good bit more than this, a good bit more organized, probably leaning on Laravel a little more. But just to demonstrate the principle here at work, this is what we've chosen to do. Now, let's say that they come back a few months later and they ask for PayPal in addition to the two existing ones. And a few months after that, they ask for Affirm payments. So you can see how this would really quickly become bloated. It'd be a pretty big method in our controller here. It would just be kind of clunky to manage and update. So this type of situation where you have to continually change existing code you've already written whenever you want to add something new, that should be a trigger in your mind that you should really consider if your code is actually open to extension, or if maybe you're violating the principle in your existing logic. Because remember, the basic premise of the principle is that you should write your logic in a way that allows additional logic to be added without modifying any of your existing code that's in place already. So to solve this, here's what I generally recommend in most projects. Find the things, the stuff that needs to change. What logic is specific? What's changing depending on what's in the request? What's generic? What seems to be the same regardless of what's currently in the request, what the user selected in this case? Once you find that thing, put each thing into its own class, implement an interface for all of the things that you created, and then reference the interface instead in your classes. So if we look at our controller here, hopefully it's pretty obvious by this point, our specific things that are changing depending on the request, well, of course, that's the specific gateway. That's the Stripe client logic. That's the Amazon client logic. That's the PayPal logic, and so on and so forth. That's the stuff that's changing depending on the request. So we'll need to make separate classes for each of those. So what's the same regardless of what gateway they choose? Well, in our kind of contrived example here, but still provable, that's the purchase method. Regardless of what happens, regardless of what the user selects as their gateway, we're still making a charge, a purchase of some sort. So that should be the interface here because that's the same across all of the gateways. So let's make that change. Let's pull all of these into their own classes. Let's make an interface that they all implement with a purchase method. And so if we look at the interface, just like we mentioned, it's pretty simple. Just a single method of purchase with some data that we want to make sure is always available for each gateway. And if we look at the Stripe gateway, you can see that we have just a Stripe specific logic here in our class. This class should always be rather small, and you'll see this even in Laravel itself. A lot of its adapter patterns, all of the things that are using those adapters have very, very small actual logic in each class. And that's because they're using this exact pattern. They're breaking things up according to what's changing and making an interface for anything that doesn't. They're following this open-closed principle. Just as a quick demo, of course, here's the Amazon Payments Gateway as well. Again, just the Amazon client-specific logic here. We're not concerned about anything else because we're implementing an interface. So if we take a look at our controller now that we've applied this open-closed principle, you can see it's much more clear now, right? It's certainly easier to read and reason about. We're not really doing anything that we shouldn't in our method. But what's important and what I really want to point out again here is that we also didn't just copy paste our bloat that was happening in that controller into another file or into another set of files and call it better because we're adhering to the principle that some guy said on the internet. No, we actually considered what was happening, we considered what was changing, and then we separated that logic into sensible areas and actually reduced the overall complexity of our code. There's no more switch statement. There's no more if condition present here. So clearly it can bring clarity to what would otherwise be pretty complex code, right? But in my experience on past projects, there are other side benefits of this too. I've generally found that when I really pay attention to this principle in projects that I manage or projects I'm just building myself, I find that the occurrence of bugs in production really lowers. There's simply less stuff being changed that was already deployed. So the reality is that you just have fewer bugs being introduced in the code base. And that's because you're extending existing logic following the open-close principle. You're not modifying existing logic. So when you think about open-close, just remember that when you find yourself changing existing code more than once or twice, when you're adding new features, you should probably consider isolating that changing logic behind an interface and then just referring to the interface in your classes. And then, of course, as always, just write in a way that allows functionality to be added without altering any of the logic you've already been writing. So next up is the Liskov Substitution Principle. This one was created by Barbara Liskov way back in the 80s, and it states that a class must be replaceable by its subclass without breaking the application. And in PHP, practically, this principle means that you just need to pay attention to your signatures, your return types, any exceptions that you might be throwing, just to be sure that you're not accidentally changing the behavior in your subclass to something other than how the parent class would respond. This is another one that would make a lot more sense with a real example here, so here's a quick demo of that. Now, let's say that we have a project where we need to fetch fields from various locations. This is an example of one little demo app that I've put together for you. Let's say this application has a need to fetch fields from the database or the file system. For one reason or another, those are two logical places, we'll say, to store fields. This is using the repository pattern. I have strong opinions on the repository pattern, but it works well here. Anyway, we can either fetch these fields, like I said, from the database or the file system. Now, if we're relying on an interface, we already are going to have some guarantees to make sure we're returning the right type, right? If you have an interface declared, you can type into the return value and say it must be an array, it must be an instance of a class or any other primitive or something like that. So we have some guarantees already in place. So to some degree, this principle is being followed by just writing PHP in a modern way with the substitution principle here. But it goes a lot more than that if you want to really adhere to it and get the most benefit from the Liskov substitution principle. And what I mean here really is this. Let's say that for one reason or another, the database response here happens to be an array with a key of values, and of course, just a single key here of fields, and the value is a list of all the fields returned from the database. But the file system response is simply a raw array of all the fields that were returned from the file system. Now, as of right now, simply implementing the interface, we're technically okay. We're adhering to the interface. We are returning an array in both methods, both classes here. Now, of course, looking at these side by side, we can tell they're not quite accurate with each other. So there are going to be some issues, but you might think this is a silly oversight to have in a project, but you would be absolutely surprised just how many times I see this happening in projects over and over and over again. But let's remember the principle and apply it here to see what it looks like. If we're using the file system repository, then following the Liskov substitution principle means that we should be able to swap out one subclass, i.e. this repository for the file system, with another subclass, the database repository subclass, and have no errors. Now, clearly, like we just said, we can't actually do that. This is violating the principle because this database class requires us to traverse the array and get the fields value. But the existing logic in the file system repo doesn't do that. So this is a perfect example, like I mentioned a moment ago, of how PHP does enforce some parts of solid, like the Liskov substitution principle here, where if you use an interface and that interface has a type into return value, it must match. But this principle, to get the most benefit from it, you need to go a little further than that. Not only must it match the primitive or the class instance, whatever you want to use in that type hinted interface, it should match as much as possible, just to make sure that we're not breaking anything that references this class here. And this extends to more than just formatting, like the keys and values of an array or something like that. There's a wealth of information on the internet to really specifically adhering to this principle. It gets into making sure that your covariant, your contravariant, and your parameters and your return types and so forth. And for most developers, it's probably a bit extraneous to get to that degree. Just make sure you're using an interface. That interface has type hinting like it does here, and the format and classes you're returning are functionally the same. They work the same. They have the same structure, if you will. And that will really go far in helping you use this principle to make sure you're not breaking any of your other code that relies on this interface returning a specific or consistent value. Next up is the interface segregation principle. And this one states that clients shouldn't be forced to depend on an interface that they don't use. And in practical terms, that just means that you should ensure that your interfaces you have in your project aren't trying to enforce too much logic. They're not trying to do or enforce or encapsulate too many different things or functions. Generally, it's better practice to create more granular interfaces rather than fewer larger ones. And in most situations, you shouldn't have an interface with more than just a few methods in it. I'm sure there are some situations like that, but by and large, it's a good rule of thumb. If I find myself adding 5 or more methods to a single interface, I'm going to take a moment to consider, number one, whether I even have the right level of abstraction here, or number two, if I have a hidden concept in my logic somewhere. And we're going to see an example of that in a moment. This principle is heavily used within Laravel itself, and it makes for, honestly, really nice code. You'll see numerous interfaces that have very few methods, often just one defined. Things like JSONable, HTMLable. Those are all the result of Laravel's adherence to the interface segregation principle. More granular interfaces where it makes sense instead of one larger one that tries to do too much. Here's a quick demo to show you what I mean. Let's say that we are given an app that allows teachers and students to attend courses online. We're tasked with fixing the implementation specifically of their interface for users. They're having some trouble with it. They've hired us to come in and fix it. So here's what they're working with. Now there are 3 types of users: teachers, students, and administrators. Each one of those classes implements the user interface, as you might imagine, which requires a few different methods. But the issue that they're having is that some methods don't really make sense for users at all. Teachers, here's the class teacher, for example, they don't really enroll in a course. They teach it, in this application at least, and they don't manage platform settings either. Likewise, students don't teach a course. They definitely don't grade other students in this application, and they shouldn't manage settings, obviously. And administrators don't use any of these methods. They use just one, the platform settings management. So all these classes are forced to add these methods that do nothing just because the interface requires them to do so. So to solve this, the interface segregation principle would recommend that we separate the large interface we have in our user interface here into multiple granular ones. Now, of course, this is a demo app, so there is no real logic for these users, but if we're applying the principle to a project, we should stop and think at this point, okay, we clearly have a use case where there's an interface that requires too much. Let's apply interface segregation and see what happens. So the first thing we need to do is think about how we actually use the classes that are relying on this interface in our code base. For the classes that implement this interface, how are we actually using them in our logic? And in almost all the projects that I've seen where this problem happens, there are little hints you can find in existing code if you're looking for it, where the interface wants to be more granular. There are methods that type hint the large interface, but they only interact with a subset or a group of its methods. For example, let's say one function of our app is managing teacher loads. Here's a little succinct example of that here. The class that handles that logic type hints a user, but really it's relying on the past user to be a teacher specifically, not a student, not an administrator. And in a real project, I'd bet that somewhere in this method, there's likely logic that's manually returning or throwing an exception if the provided user isn't a teacher. And I bet you're already thinking of similar situations in projects you've worked on where this happens, where something like this happens. So what does it look like to solve the problem and adhere to this interface segregation principle? Well, the answer is simply following the principle for the most part. Break the large interface into multiple granular ones. Now, that being said, there's a lot of conversation to be had about properly defining and using interfaces, but for now, we're just going to stick to conventions here as far as naming and structure of these interfaces. So since our project's logic, like almost any real-world project that I've ever seen, is really just relying on certain methods, a group of methods in our large interface that we tried to use initially. We can actually just break down those groups into smaller interfaces for each one of them. So here you can see we have a can teach, can enroll, and can administer interface with the relevant groups of methods inside each of them. If we scroll down a bit, you can see these user classes that we have for teacher, student, and admin are now much smaller. They only have the methods they need. There are no more extraneous methods that don't really do anything. But a side benefit of this principle is that our code is now much more flexible if you think about it. Here's an example. If we swap back to our class that manages teacher loads, we can now be explicit about what we're expecting in our method for the signature. And instead of manually checking whether the user passed as a teacher like we were doing here, instead, we know for sure we have a class provided, whatever it may be, that is able to teach. It can teach, if you will. Regardless of what the concrete class is, maybe we have tenured teachers, maybe we have starting teachers, intern teachers, perhaps. All sorts of varieties of roles and things like that for a class that could be used here. All we care about is, can it teach? Can we actually rely upon this class to have those values? If we have this interface type hinted, yes, we can. And we know for sure it's a teacher instead of trying to, as we did before, suss out whether we were given a teacher as a user or not. All of that logic that we're implicitly checking for is now explicit. It's visible here. We are expecting something that can teach. Whatever it may be, it must teach. So we can now delete all of those checks that we had manually in the logic because now it's explicit in the signature and we have cleaner code, honestly. Another example, let's say in another part of the app we're enrolling users in a course. Now we can simply type in that our method should be passed any class that implements can enroll. We don't care about what it is, who it is, what role they have, doesn't matter. All we care about, can they enroll? This method will be enrolling this entity, a class. So as long as it can enroll, we will accept it. If our application had various types of students or various roles of students, like honor students, returning students, and so forth, they can simply implement the interface and we'll know they have the methods they need, and we can just rely upon that here in our methods to enroll them in a course. So if we think about summarizing interface segregation, I would recommend you consider whether your interfaces are trying to enforce or encompass or encapsulate too much logic at once. If you have a bunch of methods in a single interface, you very likely have multiple smaller interfaces and a few hidden concepts hiding in your logic, in your interfaces. And as a general guideline, if you have roughly 5, maybe 4 or 5, depending on the size of the project, or more methods in a single interface, that should be a hint to your brain that you should consider if you can make things more granular to more closely match how you're probably actually using that interface in your code base. Our last principle here is dependency injection, and it states that we should depend on abstractions, not implementations. And this one's not as commonly encountered in projects as the others are, especially when we're in the context of the Laravel framework, just because Laravel provides dependency injection as part of the service container automatically for you. But it is still a core concept of understanding how to make clearer, more maintainable code, so it's worth talking about. And like I mentioned, Laravel's service container is the biggest example that we probably use every day in Laravel. Let's take a look at a very fast example. So in this example, we have a payments controller, and it's responsible for charging the user. Of course, this would go in the store method to stick with the standard naming conventions for method names. You can see that we're taking advantage already of Laravel's service container by type hinting our Stripe gateway here in the constructor. And this is actually PHP format. It's really nice. If you haven't looked at how this works yet, I would highly suggest you do so. But essentially, we're saying that this gateway constructor parameter should be a public property type hinted as Stripe gateway on this class. So that's really, really nice. And the reason why I'm doing it here versus in the method's signature that I'm using is because if I use this in multiple methods on the controller, it makes a little more sense to type into it here in the constructor and then memoize it on the class itself, just so we can reuse the same instance. And it's slightly faster in terms of memory and execution time. But like I mentioned, you can absolutely type hint things in the signature of a controller method, and Laravel will resolve it from the service container for you. Anyway, the problem that we have is that we're not really easily able to test this. Right now, if we ran our feature tests, they'd be hitting the real Stripe API, and even with test cards, it would still just take way too long to run our tests. And we want to keep those as fast as possible, just to make sure that they're run really often by other developers and us. So we can solve this by relying more on dependency injection, Because remember, we need to be depending on abstractions, not implementations. And this Stripe Gateway class is clearly an implementation of the gateway concept. And for that reason, it should probably be an interface. So let's do that really quickly. First, we'll create an interface that we'll use for all payment gateways so we can type in without asking for a specific implementation like the Stripe implementation. Then we will create the Stripe Gateway, of course, being sure to follow the interface. And since we want to also make this faster in our tests and kind of decouple the use of the gateway, we will create a fake gateway as well. And this is going to simply just return hard-coded test data. Now, in reality, you'd want to either use a specific test card here and return a random transaction from a hard-coded array at minimum, or something along those lines. Otherwise, if you don't, you run the risk of your tests relying on the hard-coded data here that you placed instead of proving that your logic actually works, which is what a test, especially at the feature level, is supposed to be doing. Now, we'll bind our interface into the service container to make all this work together. And it's pretty simple here. You can see this is likely going to be in your app service provider for most projects. We're just checking the environment. If it's production, we return the Stripe gateway, of course. And if it's not, we return the fake gateway to keep things really fast. And in our controller, now we need to type in the interface instead of the Stripe gateway, which we've done here. And we're all set. Now when we run tests, we're going to see much faster execution time, and we're still going to be using the Stripe gateway in production. And with that, that is our last principle addressed. Now, a few final thoughts on Solid here for those that are interested in actually applying them to everyday projects that they work in. Unless you're building packages for other use by developers, practically speaking, you're only going to be actively using two of these. That's the single responsibility and Liskov substitution principles. The other three, the open-close, interface segregation, and dependency inversion, those are mainly used either for larger projects that actually have multiple solutions and services for a given problem or a given feature in their app. Or like I said, they're building packages for release and they have a need to address all five of those solid principles to make sure that other people don't have their code break using their package. Another thought, applying this when you're actively writing code and considering Solid as you write, I'd encourage you to think of yourself 6 months from now. If you had absolutely no context on the feature you're working on, would the logic you're working on still be easy to understand? Does it make sense to you without all the context you have as you write it? All these principles work together to make maintenance easier for you in that situation. When you're 6 months out of the gate, you've already launched the project, you come back to it to add something, all these principles work together to make it easy and fast for you to add something quickly, get into the project and get out of it and keep moving. So if this video taught you something or was helpful, number one, that's awesome. Number two, I'd appreciate if you liked and subscribed and so forth. We've all heard the usual spill on that. So with that in mind, thank you so much for watching. I'll see you in another video.